Hi students, welcome to chemistry online. Today is raining continuously from the morning. So even though class we have to take, I have to take, not we, I have to take. Then in previous class we discussed about shapes of orbitals. In this class, filling of orbitals in an atom we are going to discuss. Filling of orbitals, filling of orbitals in atom, filling of orbitals in an atom we are going to discuss. This is our topic, filling of orbitals in an atom. Okay, how orbitals are filled in an atom means you have to know first about three principles: Aufbau principle, next Pauli's principle, next Hohns rule. First one, Aufbau principle, we are going to discuss. Aufbau principle. The meaning of Aufbau is building up. Building up is nothing but filling up. Meaning of Aufbau. Aufbau equal to filling up. Filling up. Filling up is nothing but building up. So, according to Aufbau, electrons enters into the orbitals, degenerate orbitals, ground state orbitals. Electrons enters into the orbitals in the ground state in increasing order. Electrons means orbitals are filled with electrons in the ground state orbitals. In the ground state, electrons or orbitals are filled with electrons, not electrons. Orbitals are filled with electrons in the ground state. Orbitals are filled with electrons in the ground state, in increasing order. Increasing order of their energies. Orbitals are filled with electrons in the ground state in increasing order of their energies. Means electrons enters into orbitals based on their n plus l values. If n plus l value is the same, then electrons enters into lower energy level first, higher energy level next. Okay, here I am taking n value, l value and n plus l value. Okay, it is a orbital. It is a orbital. It is a n value. It is a L value, it is a n plus L value. Orbital is 1s, n value is 1, L value is 0 for s orbital. So 1 plus 0 means 1. So first electrons enters into 1s. Okay, and then then 2s, then 2s, n is equal to 2, principal quantum number, L is equal to 0 for s orbital, L equal to 0 and m equal to 0 for any s orbital. Then here 2 plus 0 equal to 2, then 2p, after 2s 2p, so 2, n value 2, L value 1, then 2 plus 1 means 3, this is the way. Then 3s, 3p, then 3d, 3s, 3, so 3, 3, okay. For s orbital 0, 3 plus 0 equal to 3, then 3p 1, 3 plus 1 equal to 4, and 3d 2, 3 plus 2 equal to 5, then 4s, 4, 0, 4 plus 0 equal to 4. Here 3p and 4s having same, then electrons enters into first 3p, then 4s. So increasing order of energies, increasing order of energies, okay. So first 1s, 1s is less than, then 2, next 2s, 2s is less than, then here 2p having 3 and 3s having 3. If the n plus L value is the same, then electrons enters into first lower energy level, means 2p is less than, next 3s, okay, is less than, like this. So if here 3 plus 1 is equal to 4, 3d means 3p equal to 4, then 3d equal to 5 and 4s equal to 4. Then what happened? First electrons enters into lower energy level, means 3p is less than, next 4s is less than, next 3d, 3d. So it is 3d value is 5. Then like this increasing order of energies, increasing order of energies. What I meant to say, according to Hubble, electrons enters into orbitals in the ground state based on their n plus L values. If the n plus L value is the same, then electrons enters into lower energy level first and higher energy level next. So if you see filling of orbitals, then like this. So it is a filling of orbitals diagram. 1s, then 2s, then 2p, 3s, 3p, 3d, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5, 5f, 5f, 6s, 6p, 6d, 7s, 7p, next 8s. So this is the way electrons will be filled. Then first 1s, then next 2s, next 2p, 3s, 3p, 4s, next 3d, 4p, 5s, next 4d, 5p, 6s, next 5d, next 4d, 4 plus 6x, 6s, 6 plus 0, 6 plus 0, 6, next 4 plus 3, 7, like this, okay, like this. like this, electrons will be enters. So this is the way. So 3D, after 3D electrons enters into less than 4p, next less than 5s, next 4d less than 4d, next 5p less than 6s, and so on. This is the way, increasing order of energies. This is a filling of orbitals. So this is nothing but a Aufbau principle. So Aufbau means filling up or building up. Aufbau means filling up or building up. Building up. So orbitals are filled with electrons in the ground state in increasing order of their energies. So this is the way, orbital n value, L value, n plus L value. If n plus L value is same, then electrons enters into lower energy level first, higher energy level next. This is increasing order of energies. This is the way. Next order of 1s, 2s, 2s, 2p for s orbital, next for p orbital, for d orbital, for f orbital. Okay. So this is the way, filling of orbitals in an atom. First Aufbau principle. It is a first one, Aufbau principle. Okay. Next we are going to discuss Pauli's exclusion principle. Got it? Next, second one is Pauli's exclusion principle. Second principle is Pauli's exclusion principle. Pauli's exclusion principle. What is a Pauli's exclusion principle means? No two electrons in an atom can have same values of all four quantum numbers. If you take any two electrons in an atom, they don't have same values of four quantum numbers. That is nothing but a Pauli's exclusion principle. See, no two electrons in an atom can have same values of all four quantum numbers. All four quantum numbers. Okay, no two electrons in an atom can have same values of four quantum numbers. Same values of four quantum numbers. It is nothing but a Pauli's exclusion principle. I will explain with help of a example. If you take helium, what is the atomic number? 2. What is electron configuration? 1s2. So how many electrons in s orbital? 1 and 2. So this is the first electron and it is the second electron. Okay. Now we may write all four quantum numbers values. Orbital, next n, l, m, s values. Okay. Then it is a first electron I am going to write. First electron 1s 1. So a principal quantum number is 1. So s orbital L value 0, s orbital M value 0, L value is 0, M value also 0. So upward direction means plus half, plus half. Next second electron, n value 1 because principal quantum number, L value 0 because s orbital, M value 0, s orbital. Then s is equal to downward direction means minus half. See here, if you see all the 4 quantum numbers of helium 2 electrons does not same. So 1 1 0 0 0 0, it is a plus of, it is a minus of. So values is not same. Values are not same. Okay, it is Pauli's exclusion principle. Understand? So this is nothing but Pauli's exclusion principle. No two electrons in an atom can have same values of all 4 quantum numbers. Same values of all 4 quantum numbers. NOS is nothing but numbers. Same quantum numbers. It is nothing but a Pauli's exclusion principle. Pauli's exclusion principle. Next we are going to discuss Hohns rule. Third one, Hohns rule. What is a Hohns rule? Someone will say Hund, not Hund. Hund. Hohns rule. Okay, this is the third principle. What is a Hohns rule means? See, orbitals are filled with at least one electron, and then in degenerate orbitals failing takes place. If you take orbitals S, P, D, each orbital is filled with one electron, and then pairing takes place. Orbitals are filled at least one electron, and then pairing of electrons takes place in degenerated orbitals. This is nothing but a Hohns rule. Orbitals are filled means each orbital is filled with at least one electron. Each orbital is filled with one electron. Each orbital is filled with one electron, and pairing of electrons takes place. Pairing of electrons takes place in, and then pairing of electrons takes place in degenerate orbitals. Okay, this is Hohns rule. Each orbital is filled with one electron, and pairing of electrons takes place in degenerate orbitals. For example, nitrogen, atomic number 7, electronic configuration 1s2, 2s2, 2p3. Next, in S how many electrons? 2. In 2s how many electrons? 2. Into P, how many? 3 electrons. 3 electrons are not filled with like this. 1, 2, 1. It is wrong. Here 1, 1, and here 1, 1, and here D means each orbital filled with at least 1 electron, and then pairing takes place in degenerated orbitals. It is right. Okay, this is Hohns rule. Oxygen, we may take oxygen, 8 atomic number, 1s2, 2s2, 2p, 4. Then here how many electrons? 2. Here 2s, 2. Next 2p, 4. Degenerated orbitals. These 3 are degenerated orbitals because these 3 orbitals having similar energy. First these 3 degenerated orbitals are filled with at least 1 electron, then pairing takes place. Then pairing takes place. This is the way. Okay. This is Pauli's exclusion principle. This is a Hohns rule. Okay. Then I will discuss electronic configuration or stability of orbitals. We will discuss. This is filling of orbitals in an atom. So Pauli's exclusion principle, Hohns rule, and previously we discussed Hofbauer principle. Then stability of orbitals. How orbitals getting stability? We are going to discuss. Stability of orbitals. Half filled or full filled orbitals are more stable than partially filled. Means in degenerated orbitals are half filled or full filled are more stable than partially filled orbitals. So here we are going to discuss. So half filled, or full filled orbitals are more stable than partially filled orbitals. Okay, due to two reasons. Due to two reasons. So first one is symmetrical distribution of electrons. First one is symmetrical distribution of electrons. This is a first one. For example, p orbital. How many? 1, 2, 3. This is a px, it is a py, and it is a pz. D orbital having how many? 1, 2, 3, 4 and 5. Here 1, 2, 3, 4, 5. Symmetrical distribution of electrons means this is the way. All electrons are arranged in clockwise direction. The clockwise direction. It is a clockwise direction. All electrons are aligned in one direction. They are very stable. The orbitals is very stable. So this is the way. Symmetrical distribution of electrons means this one. Px, Py, Pz. These degenerated orbitals. These 5 are degenerated orbitals. In degenerated orbitals are electrons arranged in like this. First electron is a clockwise direction. So which gives a stability. It is a stable. It is a stable. Then second reason, symmetrical distribution of electrons. Then second one is exchange energy. Exchange energy. Exchange energy. What is exchange energy means? One electron is exchanges its position with another electron, then some amount of energy is released. That releasing energy is nothing but exchange energy. Due to energy is releasing means due to less energy, orbital is more stable. Okay. Then here exchange energy means see here, when electron exchanges its position with another electron, then releasing energy is called exchange energy. So here, for example, d orbital I am taking. D orbital. D subshell having how many orbitals? 5. 1, 2, 3, 4 and 5. Here it having electrons. How many electrons? 5 electrons. It is first one. The first electron exchanges with second electron, and first electron exchanges with third electron, and first electron exchanges with fourth electron, and first electron exchanges with fifth electron. How many exchanges? 1, 2, 3, 4. 4 exchanges. 4 exchanges. So due to 4 exchanges, it is more stable. It is more stable. So here the first electron can be exchanged its place with the second one, third one, fourth one, fifth one. Total 4 exchanges. Next, same d orbital I am taking. Here how many electrons means 1, 2, 3, 4 and 5 like this. Here I am taking second electron. Second electron having how many exchanges? 1, 2 and 3 exchanges only. Here it having 3 exchanges. It is more stable than this. Why? Because here 4 exchanges. In 4 exchanges, amount of energy released is more than this in 3 exchanges. So it is more stable. It is less than this. It is more stable than this. This is exchange energy. This is exchange energy. Okay. So this is the way exchange energy can be discussed. This is nothing but a stability of orbitals. Half filled or full filled orbitals are more stable than partially filled orbitals. Due to symmetrical distribution of electrons is one reason, and exchange energy is a second reason. So symmetrical distribution of electrons. Symmetrical distribution of electrons. This is stability of orbitals. Okay. Then we have to discuss about electronic configuration. Electronic configuration will discuss. So what is electronic configuration and electronic configuration of some atoms we have to write. So this is briefly stability of orbitals. What we discussed in this class means filling of orbitals in an atom. Filling of orbitals in an atom by using three principles. First one is a Hohns principle. Second one is a Pauli's exclusion principle. Third one is a Hohns rule. According to Hohns, electrons enters into orbitals based on their n plus l values. Second, Pauli's exclusion principle. No two electrons can have same set of all four quantum numbers. Then Hohns rule. First, orbitals are filled with at least one electron. Then pairing takes place in degenerated orbitals. Next, stability of orbitals. Stability of the orbitals. Half filled or fulfilled orbitals are more stable due to two reasons. Symmetrical distribution of electrons. If all electrons in one direction, then stability is more. Next, exchange energy. If one electron exchanges its position with another electron, then some amount of energy is released. Then that is nothing but exchange energy. If exchanges are more, stability is more. Okay, bye.